Good morning and welcome to the 21st annual exhibit of hydrogen and fuel cell technologies. We've added batteries to the mix and we'll be discussing all of these technologies briefly. We welcome you to have a seat. The drinks are on the house and they'll be served swiftly. Relax and have some information. It has been a romantic battle, 20 years in order to launch this technology, and we're discussing still the improvements. It's something like Don Quichote, who's always been tilting at windmills, but there's a lot more facts to discuss. About these facts, we'll be talking with Denis Thomas, who's in business development of power to gas, taking electrical energy and converting it into hydrogen and other useful fuels. He is the business development at Power to Gas and from the fuel cell and hydrogen joint undertaking, and he'll be talking about linking wind power with electrolyzers and forklift trucks. Welcome, Denis.
Yeah, thank you very much for the kind introduction. So the idea this morning is to present you an update about the project Don Quichote in Belgium, which is linking wind energy to hydrogen and to power forklifts, hydrogen forklifts. So basically, what is this whole project about? What are the project partners? Is to develop an innovative concept of hydrogen out of wind electricity. That's a project which started in 2012 and which will end in 2018. That's a funded project by the FCH JU. 60% funding, and the project partners are Hydrogenics, meaning that we supply the electrolyser technology, Waterstofnet, which is like the hydrogen association in Belgium and in Flanders, Colruyt, this is the client, they are using the hydrogen, this is a retail company in Belgium. TÜV Rijnland, I guess you know them. The Joint Research Center is the research center from the European Commission. Icelandic New Energy, that's a hydrogen company in Iceland. And then FAST and the European Hydrogen Association for the dissemination part of this project. So the project setup is as follows. There was already an existing system at Colruyt, so this is the logistics center of this retail company, and they invested in a previous project in a hydrogen refilling station from Hydrogenics here, and there you see this is the alkaline electrolyzer container, this is the hydrogen compression and storage container, and here is the dispenser. And they use the hydrogen to power hydrogen forklifts here in their logistical center. And the Don Quichote project, the aim of this project was to add a second line of electrolyzer technology with a different technology, a PEM technology, proton exchange membrane technology, with the same output, hydrogen output as the alkaline, to add as well a different type of compressors to be able to compare the performance of the compressor and add a different type of storage. There is also the inclusion of a fuel cell in the project. So the idea is to make a kind of benchmark analysis between alkaline and PEM technology, and also regarding compressor technology, and to study the various business cases of hydrogen in such a setup for Colruyt, and study the re-electrification option and the mobility options. In the Don Quichote project, there are three phases. The first one was to monitor the previous system, meaning the alkaline electrolyzer. Phase 2 was about installing this new PEM unit and monitoring it. And the phase 3 is about extending the system with an additional compressor and monitor the performance of this new compressor. So these are the drawings. So the first system is here, and the new system is there, and the completed system looks like this. This is the PEM cell stack, the 30 noble cubic meter per hour. That's more or less 150 kilowatt power for the electrolyzer. And what you see on top of it, it's all the balance of plant. And this is how it looks like after completion of the project. And on the top of the container, then you get some hydrogen storage, 450 bar, and the cooling unit. Who is consuming the hydrogen? Who are the users? Mainly the forklifts, At the beginning of the project, there were 5 forklifts using the hydrogen. As of now, they have something between 12 and 15 forklifts working on hydrogen, but there are also a few hydrogen cars making refueling, and sometimes hydrogen buses from Belgium going to that place to refuel. So what are the main results? Basically, we managed to develop the new project, get it certified, and all the permission to do that. And we get data about refueling. Up to the beginning of the project, we managed to have more than 3,000 refueling experience and more than 2.5 tons of hydrogen delivered to the final customers. And there was a training and the implementation of the life cycle assessment and the total cost of ownership analysis, because it's definitely part of the project. It's not only about technology, it's also about how to have a business model around this application. This is a representation of the typical project setup, meaning that, and because the results I will present results regarding the performance of the system. So what do we mean by performance? It means that we monitor all the power input in the system. So the power input on the cell stack, in the transformer, but also in all auxiliaries. And we also monitor the power consumption from the compressor. And at the output, we monitor, of course, the hydrogen output out of the electrolyzer, and then how many refueling in the system. These are the results of phase 1, meaning that here we can see the amount of hydrogen that has been delivered to the clients, the forklifts and the cars, from February 2014 up to February 2016, with an average of 50 kilograms per month. So it's not a huge amount. And these are typical electricity consumption, average data, monthly basis, about the consumption of the compressor that you see here, the average consumption of really the electrolyzer system and the cell stack mainly, and then the top part about the control unit and utilities. So this was the main result from phase 1. For phase 2, these were the expectations at the beginning of the project in 2012 when we submitted the project proposal to the FCH JU, who is financing this project. Basically, what you see here is a representation about the current density that can be applied on the electrolyzer and the efficiency. And what you see here in blue, that's a typical curve for alkaline technology. And regarding PEM technology, it has been demonstrated that we could operate the system at higher current densities, up to 2 amps per square centimeters. And we expected the project to be somewhere in this range, so between the blue and the green curve. So these are the results that we got from the project in terms of cell voltage. So these are data from September to December of last year. And you see that when we increased the current density, we increased the cell potential, and it gives an idea about the efficiency of the system. And you see also the impact of each month in this data. And I think this is one of the most interesting slides regarding the PEM cell stack performance, because on this graph you can see here the efficiency of the cell stack, which is of course decreasing when we increase the current density. And at the same time you see at which current density we have operated the system during the 4 months monitoring campaign, at least the first monitoring campaign. So typical efficiencies are in the range of 95 to a little bit below than 80% based on high heating value here. Then a few additional comments about specific efficiencies. So what do we consider when we calculate efficiencies? Basically, that's, as I mentioned, all the power consumption, and we monitor the hydrogen output. These are results that we observed during the 4 months duration of the campaign. So this was the electrical input. This was the losses from the transformer. So we can calculate the efficiency of the transformer. And this was the incoming electricity input to the cell stack. And this was the hydrogen output. So basically, at the cell stack level, we reach an efficiency of 4.47 kilowatt hour per noble cubic meter of hydrogen, which was in line with the expectation. Then we wanted to get also more information about the utilities and really to monitor, okay, how much power do we need when the system is at standstill. So we monitored the system when there was no hydrogen production, and we can see here that, for instance, all the utilities, they were consuming something like 1 kilowatt on average when there was no production, and the process part was somewhere below 3 kilowatt. And that's what we can see here. So if we add this additional electricity consumption, then we have a system efficiency around 5.25 kilowatt hour per noble cubic meter of hydrogen. And then if we include as well the power consumption from the compressor to reach the 450 bar storage, then we reach a value of 60 kilowatt hour per kilogram of hydrogen. So on the system efficiency, we are somewhere around 70% efficiency. There was an opening of the Don Quichote last month with the FCH JU authorities and with the director of managing director of Colruyt, a well-attended opening. And these are the summary and the next steps of the project. So basically, phase 1 is completed. There was a successful implementation. Results are above initial expectations, and we are still monitoring the system to get longer-term measurements of the system and see how it could degrade in the future. Up to now, we don't see any degradation in the performance of the cell stack and the electrolyzer system. Regarding phase number 3, we expect the new compressor to be installed by the end of this year, and then there will be monitoring of the performance of this new compressor. We started also the study about the business cases and the upscaling strategy of this, because it was a small scale. How would it look like if we have a much bigger system? How can it be transferred to other locations, to other retailer companies, to other logistics centers? What is the business case behind it? The good thing is that there is already a business case for Colruyt, because the refueling station and the forklifts, for them, they gain a lot of efficiency in the operation of the daily workers, because previously they were using battery forklifts, and they need a lot of time to change the batteries every 8 hours. And with hydrogen, they just need 3 minutes or less than 3 minutes to refuel it, and then they can start again. So the business case is there. They don't need any support to buy the forklifts. So as I mentioned, they had like 15 forklifts today, and they already committed to have 70 forklifts in the next 2 years, and they have plans to have up to 200 forklifts for the future. So these are the main results of the Don Quichote project, and I will be happy to take any questions. Thank you for your attention.
Thank you very much. Very interesting presentation. Are there questions from the audience? We have one there.
Hello, thank you for the presentation. About technologies, were there different technologies for compressors and storage system, or was it just the electrolyzer that had different technologies to be compared?
Yeah. So as of today, in phase 2, we just have 2 different electrolyzer technologies. The new compressor will come by the end of this year. So the idea, the existing compressor is a typical piston compressor, offer compressor. And we are now in the stage of implementing the new compressor technology. But there has been some questions about the type of technology we are going to use there.
Are there any other questions from the audience? I just want to clarify the statistics because I find this so impressive. The system efficiency, that would be measuring the current from the wind turbine and seeing how much is actually delivered in the vehicle, is 70%.
So as I mentioned, 70% relates to the system efficiency before compression, and the oh, it's not working anymore. Fine. No. So we were in the range of a little bit below 60 kilowatt-hour per kilogram of hydrogen.
Mm-hmm.
So this is like the overall system efficiency.
Why I find this so remarkable is, of course, you could make the argument, why not just dump this electrical energy into the grid? The grid itself can have a loss of 30%. The whole genius of this system, of course, is that you're producing locally. It is on-site production. It makes you flexible. You do not need to have a grid if you're operating off-grid somewhere. It is reliable. I'm like just thrilled. I find this very impressive. And what you said about the logistics companies who use these forklift trucks, this is a business model. This is not Don Quichote. There are a number of areas where forklift trucks operate indoors. Of course, they can't use diesel. You need 3 sets of batteries for every forklift truck. So although the PEM cells are expensive, it's cheaper. So this is a thrilling thing, and I really like this take on on-site production of energy. How are you going to move forward? What's next?
You mean for Colorado or for
well, are you
project?
marketing this somewhere else? Are there people lining up to say, you know, where can we buy this system?
Yeah. So basically, there is a lot of interest for this project, especially on the forklift case, because a lot of people are looking at solutions for internal mobility in companies, in logistics centers, and very clearly there is something to be done on that. And the business case of a hydrogen refilling station inside the premises of a company is a profitable business case because it's like a captive fleet. They know how many forklifts do they have, and they can, let's say, size exactly the refilling station for the demand of hydrogen. And what's next as well is that Colorado is also owning a network of refueling station in Belgium, and they plan to connect this system to a close-by hydrogen refilling station. So they will connect it, and it will be like the second hydrogen refilling station, public one, open in Belgium. And we expect this also in the course of this year. Mm-hmm. So these are really positive results. They really believe in hydrogen, and they are a strong supporter of hydrogen in Belgium.
Mm-hmm. Okay, this is a remarkable presentation. I'd like to remind you all that Denis Thomas is going to be back here at 3 o'clock in the afternoon for a series of presentations of electrolyser technologies. It's called an elevator pitch. You'll be joining 8 other individuals here. Why is this so important? Germany, of course, has an excess of wind energy, and we're currently turning turbines off because the grid cannot absorb it. We have not developed enough storage capacity in order to use all this energy. It's not that we don't need it, but there is a running debate on what we can do with electrolysers. Should we feed the hydrogen into the grid? If that's possible, do we have to methanize it to do that? Are there other storage facilities? It is a huge debate, and we're talking about a large share of our power consumption, potentially. So this is very important. This take I find very impressive because it gets back to the heart of our hydrogen fuel cell industry, producing and consuming on-site, decentralized grid. So this is very thrilling and very important information. Denis Thomas from Hydrogenics, it's been a pleasure talking to you. Thank you very much for the presentation.
Thank you very much for your attention. Thank you.
And thank you. We'll be continuing in literally 2 minutes with our next presentation, so stay tuned, have a drink there on the house, and we'll be back in a minute.